Hello, I'm Dr. Mark Lewis. I'm an associate professor at Trinity University, and I wanted to record a version of the tour talk that I give for students who come and visit the Trinity campus. Hopefully, if you're watching this, you're considering your options for where to go to college. Possibly you have an interest in computer science, and you definitely should. I have a Prezi for recruiting that at least if you got an email with this link, there's probably a link to the Prezi as well, which gives you some of the reasons why you should study computer science. It's an awesome field and there's lots of cool stuff happening in it. Now, in this talk, I kind of spend more of my time on the why you should come to a school like Trinity if you want to do that. So normally this is a talk that I'd give when you come and you visit campus, and then of course you get to see the beautiful campus and you get to see our facilities. In this case, it'll have to work to just walk through the main points. So some information about the Trinity Computer Science Department. We currently have 5 tenured and 2 tenure track faculty in the department. We also have 3 visiting professors or instructors that teach the computer skills class. This is a non-majors class, so the tenured and tenure track faculty teach all of the majors courses. There is a computer skills requirement though, and so we have some instructors to help teach that, which is wonderful because it allows me to continue teaching the majors and the courses that I love to teach. Right now we have about 70 majors in the department. A lot of our students will choose to double major. This is actually very common across the Trinity campus. This number, changes. It's a very rough estimate, but yeah, we sit at about anywhere from 50 to 100 students in the department, and we're actually in a growth phase right now. So the facilities that we have 3 class labs. In our current building, these seat 21, 21, and 18. In the spring of 2014, a new science facility opens at Trinity, and computer science will be moving into it. And we'll still have 3 classroom labs there, but they will all seat exactly 20. And that's really a significant thing for you to take note of. You could go to a large state school or to a technical school and get your degree in computer science, but then you're going to be in a classroom that has 1, 2, 300 students in introductory CS. And I don't know, it's my opinion that if you're going to pay for college, you should get the individual attention of actually having faculty who know who you are, who will recognize you, probably hopefully know your name. And that's really not possible with really large classrooms. The size of our courses are really fixed by the size of our classrooms. In the introductory courses, we will actually fill those classes, but in our upper division classes, we'll have, I think probably 10 is about the number of students that we average in there. We also have 2 non-classroom labs in the new building. Our non-classroom space goes up a bit. This is space where students can kind of hang out, work on projects. They're good for social spaces. For example, our ACM, the Association for Computing Machinery, which is kind of the national and international organization for computing. We have our student group, and they hold events in there, but also students just come up there to work on their assignments and whatnot. And one of the major things that I have to point out here is our regular upgrade cycle. So you're all aware of the fact that computers don't age well. A 5-year-old computer is pretty much a doorstop, paperweight, whatever it is that you want to refer to it as. And so anytime you go and you visit a college, they'll be happy to show you their fast new machines. But you have to realize, if you're not even a student there yet, it's going to be 5 years before you're a senior, you're working on your big projects, and what might be a nice, fast, shiny new computer right now, in 5 years, is going to be a doorstop. And so what really matters much more than what machines they can show you when you visit a campus is how they intend to keep buying more machines to make sure that they have up-to-date facilities. Some things about our curriculum. We start off with a 3-semester introductory sequence. So the first semester is an introduction to programming, and we use the Scala programming language for this. And that's followed by an object orientation class. And once again, that's in Scala. Scala is a fairly new language. Its primary implementation runs on the Java virtual machine. So you get the power of the Java platform and the ability to run it on any operating system or whatnot that has Java installed on it. But Scala is a much newer, more expressive, more powerful language. It contains features that are hybrids between functional and object orientation, and it really is a cool language to learn, but for our purposes it's a really great language to teach you the things that we want to teach. And that's one of the things about how we do our classes is we have certain core concepts. Just like machines don't age well, turns out that whatever is bright and shiny new technology in computer science also, that phases out very quickly. And so there are some key foundational concepts that we really want to focus on to help you get the ability to teach yourself in the future, because that's what's going to matter most. Our third semester course is a course on data structures, and that really is kind of the entry gateway to the major. Once you've taken that course, you can take just pretty much anything in the major except for the things that are advanced whatever, and they have a course before them. That is followed by an algorithms course, also done in C++. And after that data structures course, things, as I said, they open up. You have a lot of options. We require a theory class. We require that you take some software engineering, and that you pick classes from some different groups. So for example, you have to take a course in the applications group, you have to take a course in the systems group, and you have to take a course in the design group. But we try to make it so that our curriculum is very well balanced. It needs to give you just enough of what's hot and new now so that you can land that first job, but we really want to focus much more on the fundamental principles of computer science so that you can continue teaching yourself and keep your skills up to date. Of course, the why should you major in computer science? There are so many reasons why computer science is a wonderful field to be in right now. From a parent's perspective, one of the big ones is the job market is really hot. Our majors are, actually I just had a student, so I'm recording this at the end of September, and I just had one of our seniors accept a job that he will start after graduation in May. So that type of thing is not uncommon. In fact, we have had seniors accepting jobs as early as September or early October for several years now. And most of our seniors will wind up having multiple job offers. And part of that's just computer science right now is a really great area to be in, and it has wild growth because computers run the world. But there are other reasons. You don't just want to go into a major because it has a good job for you at the other end. That's a good reason, and it's definitely something that's nice to have. But you want to enjoy what you're doing. For me personally, computers are a creative outlet. I love to code. I love to take and bring things into existence by writing programs. And compared to, for example, drawings or paintings or sculpture, or even creative writing, if I were to write a novel, the programs that I write are far more dynamic, they're far more powerful, and they have the ability to do more than pretty much any other creative media. And people don't normally think of programming and because they think of it as a technical field, not a creative field. And they couldn't be more wrong, because computers really are the ultimate mode of creation in today's world. And so, the entire act of writing a program is you just take ideas that are in your head and you bring them into existence on the computer. Much like if I were to paint a picture, I'd have a picture in my head, an image of what I wanted, and I'd bring it to life on the canvas. It's just that what I get to bring to life is so much more powerful and complex because it's running on the computer. In addition, lots of the stereotypes that exist about computer science are basically wrong. You're not going to sit alone in a cubicle and just type away in the dark. There are times where there are CS majors who want to do that. I like to tell perspectives that the only way you get to do that is if you're really, really good. You have to be so good that a company is willing to keep you on board even though you don't play well with others. In reality, software development is done in teams, and so the most valuable people are the ones who can work well with others and also work with customers. You have to be able to communicate with other people. And that leads into this question of why you should do this at Trinity. So a little bit of background about myself. My PhD is actually in astrophysics and planetary science, and I have a master's degree in computer science. And in the planetary science field, we have what's called the Goldilocks paradox, which is why is Venus too hot and Mars is too cold and the Earth is just right. And I think that when it comes to colleges and the sizes of colleges, there's a similar type of thing. Some schools are too small, some schools are too large, and of course, Trinity is just right. Why is that? Well, if you go to larger schools, and this isn't just really the big flagship state schools. Obviously, if you go to those schools, you have introductory classes with 500 students, and you are a number. You have to be a number because there's just so many people that they can't get to know you. But even if your school is a little bit smaller, if you go to a school that has graduate students, and one of the things that I really have to stress about Trinity as a great strength is there are no graduate students at Trinity in computer science. Turns out we have 3 master's programs in education, accounting, and healthcare administration, but they're very, very separate, and they don't impact computer science at all. I do research at Trinity. Okay? This is one of the Trinity's not too small things, is that I get to do research, I publish things, and I want to work with students on that, and the students that I work with are undergraduates. If you go to a school that has graduate students, they have to have a pecking order, and they have to in part because they have to get grants that pay the graduate students money. So in certain ways, the graduate students' needs have to come before the undergraduates if you have graduate students. And that's not the case at Trinity. We get to focus solely on teaching our undergraduates. And the flip side of this is we're also not too small. Computer science is a resource-intensive field. You need to have a school that has a significant endowment is very helpful. It's also nice if you have the ability to have professors that are actively engaged in research so that they can engage the students in research. And we get to do that at Trinity. Another aspect of this is, there's the question, why should I go to a liberal arts school if I want to major in a technical field like computer science? And the reason is because you want to advance in your career. Okay? The technical aspect gets you that first job. But if you want to go from being just an entry-level programmer to being a team lead and then to being a manager or an architect over an entire team of developers, that's where you need to have the communication skills, and you need to be able to write. And those are the types of things that a liberal arts education gives you. Okay? So you really don't just want to be technically trained. If all you have is the technical training, you probably will get a job, but you'll kind of be stuck in that entry-level job for the rest of your life. You want to have the well-rounded education and all of the skills that come with a liberal arts education in order to move you up very quickly. In fact, I have a fair number of former students who will lament to me that they've advanced too far in their job and they're not allowed to code anymore. Because some of them are like me and they just love to code, and they move up. Now, of course, their salary went up accordingly, and they do get to code every so often, so they're not lamenting it too much. But it's one of these things. They've moved into higher positions, and they've done that because they have the strength of a liberal arts education behind them. Another thing about Trinity when it comes to computer science is that we have a remarkably strong department for a school Trinity's size. So if you look around at a lot of the smaller schools, you'll see that often you have departments of math and computer science. Okay? If you look at other schools that are Trinity's size, that is not the case with Trinity. We are a computer science department. In fact, Trinity's computer science department has been independent since it was founded in 1970. And in 1970, we were the only undergraduate computer science department in the state of Texas, in fact, through most of the South. We had an undergraduate computer science department before UT, before A&M, before Rice, before any of the other schools that you might think of in this area that would have had computer science early. Many of them had graduate programs, but Trinity was the first undergraduate, and we have been an independent computer science undergraduate department ever since then. And so we actually not only we're an independent department, the faculty that we have are strictly computer science. Okay? So that's what we focus on. If you look at other schools where they're, for example, math and computer science, you really have to ask the question. Yes, they have 12 faculty, but how many of them are math and how many of them are computer science? And in that example, you'd actually expect that much of the time you'll have like 9 math faculty and 3 computer science faculty. So we have a remarkably strong CS department for the fact that we get to teach you in classes of 21 students, and that's a very rare combination. Lots of our students will go off and get internships. Typically, you do this after the sophomore year. However, strong students will get internships after their first year. Because of the nature of computer science, there are kind of 2 different types of internships that are available. There's the academic internships, where you go to a university, possibly Trinity, and you do research with professors there. So we generally have several Trinity students working over the summer doing academic research, but a lot of our students will go to these programs called RAUs. It stands for Research Experience for Undergraduates. They are held across the nation. They're funded by the National Science Foundation. And so a lot of the students who want to do that type of work will go off to other schools and work with the faculty there and groups of students at those locations. Of course, there are lots of jobs in computer science too. And so we have a number of different industries that will specifically try to grab our students. The student that I mentioned who has accepted his job offer in September, well, he had an internship with that company. And the reason that company likes to do the internships is that way they can hopefully lock in the students. They wanted to hire him, and that's why they brought him into the internship. And he's not alone. That happens a lot. So there are a number of local companies that recruit very heavily from Trinity, and when it comes to internships, a lot of it is based upon student initiative. If you see an internship that you want to do, wherever it is. We've had students who go to places like Microsoft and Google. They see something they want to do, they apply for it, and all of those things are possible. Of course, what parents generally care about is what happens to you after graduation. After you've spent money on going to college, you're not supposed to move back in with your parents. And right now, as I've mentioned before, computer science is great for jobs. Now, Central Texas happens to be a very low cost of living place, and so the fact that our students are getting salaries around $55,000 in San Antonio means you can live really well. Turns out to have the same standard of living in California, you need to be making 6 figures. And if we have students who go to work in other places, they will get those higher salaries. Though a lot of our students choose to stay not necessarily in San Antonio, but in the Central Texas area. Austin, as many of you might know, is also a hub for tech, and so people will go there as well. We also have a fair number of students who will go to graduate school. The percentage is reasonably low. It's about 15 to 20% of our students will choose to go to graduate school. Honestly, many students that I feel would have gone to graduate school will wind up being seduced by money at the last moment. And we have virtually a 100% placement rate for getting students into graduate school. In the last 20 years, we've had 1 student who hasn't been placed in grad school who wanted to go. So, our program is very successful at getting students into whatever it is that they want to do in the rest of their life. So after watching this, hopefully you are looking at other schools. You should be. There's due diligence here. And there's a set of questions that I think would be good to ask any school that you are considering, especially if you're considering them for computer science. You need to know if they have teachers who are there to teach. Okay? If you're working at a school like Trinity, you're in small classrooms, we're here because we want to teach undergraduates. That's why you take a job at a place like Trinity. And you have to worry about that for large schools. A lot of times you'll have people there, they're just there for the research, and teaching the undergraduates can be a burden. So you need to watch out for that. On the flip side of that, do they have facilities and faculty to support research, to support a computer science program? I have some handout material that I give when students visit the campus, and one of the things we like to highlight is a lot of our students actually publish while they are in undergraduate, and that looks great on a resume. Even if you're not thinking of going to grad school or that's not what you want to do, if you can publish a paper, it shows that you have the ability to work on something and push it through to completion. Does the school upgrade their machines regularly? You don't want their machines getting old on you, no matter how bright and shiny and fast they are today. Are they an independent department? Are they computer science only? Or are they merged with something else? And if they are combined with something else, you need to ask how many faculty there are that are actually just straight computer science. And then, of course, what is their curriculum like? Do they give you the set of skills you need to give that first job, and then also give you a firm foundation to continue your learning and to extend your knowledge in computer science? So that's it for this presentation. Hopefully you've enjoyed it. If you have questions about Trinity, feel free to email me. My email address will be in the comments of this video, but just in case, it's mlewis, M-L-E-W-I-S, @trinity.edu. And you definitely should come and visit campus and get to see come by to see what we have to offer. Thank you.